Welcome, I'm Bruce Morey, Senior Technical Editor of Manufacturing Engineering Magazine, and this is a webinar brought to you by SME's AM community for Voices Amplified. Our topic today is how to implement AM within your organization. Integrating additive manufacturing into your organization is key to your future survival and success. Integrating AM is not just about technology, but also dealing with people and change. We have two speakers today to help us understand how to implement AM in your organization. Kevin L. Ayers is the Additive Manufacturing Specialist and Consultant for 3D Metal Consulting. Kevin is also a member of the SME Direct Digital Manufacturing Advisory Team. He has worked as a design and manufacturing engineer for over He's design and manufacturing engineer for over 31 years with FBI, SMA, and Danfoss. Most of that time, he's been directly involved in what is now called additive manufacturing. Trig Rogers, sales manager for Beehive 3D, is a 5-year veteran of the additive industry. Trig has worked on the Danfoss corporate additive manufacturing team for the majority of his career. And you can see on the screen now the two speakers that are going to be presenting today. Before I turn things over to them, I'd like to outline how the webinar will proceed and a couple of housekeeping items. On the right side of the screen, you'll find a question and answer box. If at any time during the presentation you'd like to ask a question, please type it in this box and send it along. These questions will be answered at the end of the presentation. Should we run out of time, the questions will be sent to our speakers and you'll receive an answer by email. Should you experience any difficulty during the webinar, such as a blank screen or a lack of sound, please use the Q&A box to alert us, and we will respond individually in writing with a suggested fix. That brings us to the final housekeeping item. Should you experience a difficulty such as this, the presentation will be available in recorded form at about 4 p.m. Eastern today. You may then watch the recorded version of this webinar at a time and place when you have more bandwidth. You may also watch the webinar as many times as you wish to catch details you might have missed or for any other reasons. All you must do is sign in again using the credentials you used to join us now. You may even share those credentials with colleagues who might benefit more from learning about this topic. Now, let me turn the microphone over to Kevin. Kevin?
Hello, everyone.
First speaking for you. So, go ahead.
I've been in the industry since the late 1980s, and when we first got started, it was called rapid prototyping and then freeform fabrication. Now it's called additive manufacturing and/or 3D printing. Just to note, those terms are interchangeable today, but most professionals in this industry in additive manufacturing refer to it as additive manufacturing. So I'll help you start. So what is additive manufacturing? It's basically the construction of a three-dimensional object from a CAD model or digital 3D model, usually done layer by layer. It's in all industries right now, which is a very good sign, being used successfully. And materials range from metals to polymers to ceramics, composites, food, and living tissue. I'll take it over to Trig, give you a big history of what's going on in the industry. Trig?
Thanks, Kevin. So on this first slide here, you can see a brief history of AM, and I'd just like to touch on a few of the points in here to kind of give you an idea of where industry trends have gone. So the origins are in the early 1980s, and starting in Japan with Hideo Kodama inventing the first layer-based resin manufacturing process, with the intentions being that he would use it for rapid prototyping. However, there wasn't really interest in his idea, so he kind of moved on and worked on other things, and Charles Hall eventually became the first to patent and commercialize the SLA system. And SLA, or stereolithography, was the first additive manufacturing method to be commercialized and used primarily for rapid prototyping. But Chuck started a business called 3D Systems, which is still around today and still very, very popular today. And that kind of started the origins of additive becoming a real process. So in the next few years, what really happened and changed was there was a kind of boom that allowed more users to get in. And we kind of refer to that as the desktop FDM boom of the mid-2000s, 2010s. This kind of started when Stratus's FDM patent expired and opened up the market to new vendors. So we've talked a bit about rapid prototyping, but additive is really a production process. And in the mid-2010s, this came to a head when GE got their LEAP nozzle certified for flight. In the 5 years since, 100,000 plus metal fuel nozzles have been printed, and that nozzle in the bottom right is the GE LEAP nozzle. And when you have that many parts flying, it's impossible to ignore that additive is a real production technology and can be used for real parts. I mean, you've got metal parts in jet airplanes that are flying and flying reliably over and over again. The reason that that's such an interesting case study is because it combines a lot of the best parts of additive manufacturing. It combines assembly consolidation, engineering value, lightweighting, and actually a decrease in risk when you factor all those things in. So where we are today, you can see that I have that 2019 point that says over 173 printer OEMs are in the world. Today, that number is closer estimated to about 3,600 plastic OEMs and about 210 metal OEMs. And that's based off some industry knowledge. I know Kevin's done some digging on that to get into those real numbers. So these are kind of the important industry sectors in additive. And, we're taking this from kind of a beginner point of view because we're assuming that a lot of the people that are tuning into this are just trying to figure out how to implement additive for the first time. So I'm going to go over each of these industry sectors and why they're important to additive and why they can't be ignored. So hardware, these companies make the printers. Some examples of OEMs are Stratasys, EOS, Carbon, SLM, and Prusa. And there are many, many different types of technologies within the broader additive manufacturing. So when we refer to additive manufacturing, it sounds like one process, but there are actually many different sub-technologies within that additive manufacturing landscape. As far as materials go, I know Kevin touched on this earlier, but there are metals, plastics, sand, paper, wax, carbon fiber, a bunch of other things. And what you'll run into with some types of hardware is that some suppliers will require use of their own materials in their machines, so you have to buy through them. But that's not the case with every printer or with every material player. There are some open source printers in various different fields. It could be open source plastics, metals, all sorts of things. You don't have to use OEM powder for everything. One other point here that's important is that the major material players in conventional markets are opening up to the additive market. So DSM, SABIC, BASF, GKN, all of those have additive divisions where they're making materials for 3D printing because they've determined that it is a key competency, key part of their strategy going forward. So that should tell you a little bit about the direction the industry is heading. It is for real, and it's not going away. Peripherals are very important because most of the time you print an additive part, you're not going to have a finished part right out of the machine. So machining, like CNC machining, pliers, as you can see I have on there, vapor smoothing, hand sanding are all different post-production processes. And if you're going to use these processes in a manufacturing setting, you have to have these processes quality controlled to the same level as printing. It really needs to be controlled to the same level that any other manufacturing process would from a quality standpoint. One other thing that's important to note with peripherals is that some companies make solutions that are tailored to AM processes. And if you're looking at a specific process, there might be a solution that's already really good for that. Software is the heart of AM, and without CAD, there's nothing to print because we're doing this based on a digital file and creating layers based off that. Software can include CAD, additive manufacturing CAD, build prep software, manufacturing execution systems, ERPs, simulation, file security, quality management, and much more. And there are all of these different software tools are things that you're going to have to decide whether you need to implement them or not, whether you can get by without them. The last pillar here is quality control, and I think it's incredibly important. At Beehive, we're striving to always do our best with quality control, and get our processes under control, really understand the deep dive into those processes. Because without process control, you don't have a commercially viable product. So quality management for additive can take traditional forms such as CMMs or calipers, or it can take new forms such as ultrasonic non-destructive technology, CT scanning, blue light scanning, things of that nature. And one important thing to note with additive is you can actually digitally modify that CAD file. So if you have quality problems, you can go in and just make digital modifications to that CAD file and potentially reprint it and get a better result. But all of those things are things that you have to determine in your corrective action plan. Quality can even be tied to build plate location in some cases. So like if the laser is performing differently at different locations on the build plate, it could give you different parts in those different locations. Before I kick it back to Kevin here, I'm going to talk about value drivers in AM and why you might be able to take advantage of some of these and squeeze either a little bit of value or a little bit of cash out of your org. So starting at the top left there, rapid prototyping is kind of the origins of the industry, and it's still a very, very key competency, but it's not the only competency anymore. Another part of rapid prototyping could be rapid iterating. So you could do very, very fast iterations, just getting your parts printed, getting some feedback on the dimensions, and then reprinting those parts so that any design changes that need to be made can be evaluated rather quickly. Mitigation of supply chain disruptions. This is another really important one. So if you have parts that you can't get from a supplier, maybe they're overseas, maybe your parts are stuck on a ship outside of Los Angeles, you could potentially print those parts if they qualify. So, I mean, you can go ahead and qualify those parts either ahead of time before this problem ever arises when you're doing new product development, or you could qualify them when the problem arises. Either way, there's a good chance that you could end up with a solution that could save you time in getting parts out to your customers or getting assemblies out to your customers. So that's always something to consider if you're in a pinch. Another pinch that you might end up with is your manufacturing line is down because a part is broke. Well, if you use additive effectively, you could design that part and print it in-house or print it at a supplier and quickly have your assembly line back up and running again if it's ever down. Moving on to the engineering values section, I think this section is going to become more and more important in the future. In the past, it hasn't had great prevalence because we're really just getting into the weeds on how to design for additive. But lightweighting has been a key component of value within the additive world for the last really 30 years. And it will continue to be so in the future. But other types of optimization, such as generative design, are becoming available too. And this can unlock the design potential of additive manufacturing. If you pair it with simulation and create as close to perfect of flow path, thermal heat transfer solution, or magnetic optimization, you could potentially see some more engineering value in your products in the form of performance or less energy used or something along those lines. That last bullet point under design freedom, assembly consolidation, good example of that earlier was that GE LEAP nozzle. I think they went from 42 parts down to 1 when they did that, and they took a lot of assembly time away from operators. So that could save you money. It could make your part more robust and stronger. It could enable design freedom. Let's say you wouldn't be able to print a complex internal channel before, and now you have that freedom. Those are all benefits that could come from assembly consolidation. And the other point on engineering value I wanted to touch on was customization. So you could have a custom material, custom alloy for a metal, or you can have as custom of a design as you want. If you have customers that are printing consumer goods that could have like a name or something on them, that's a good source of customization value as well. And the last point there, money, which we all know is pretty important for most manufacturing orgs. you can print low volume parts at no tooling cost. So you're not paying to make a mold or a pattern for this part. You're just directly printing it. So this applies in production, tooling, and prototypes. If you have a production part that you're wanting to manufacture, but it's going to be really expensive to tool up, you could just go and print those parts directly if they qualify. The final point of value is lower or no inventory costs, and this kind of ties into what we call a digital warehouse. So you can actually have your sales and after service parts in a digital warehouse, digital repository. So whenever a customer orders a spare part, then you just have to go ahead and print it. Of course, the caveat with all these is that they qualify for the needs of the part. I kick it back to Kevin so we can start getting into how you would evaluate your organization.
So in previous jobs, I worked for the FBI, implemented additive there in SME, and working with Trig for 4 years at Danfoss, doing additive. And over the years, mainly from trial and error and some good thinking, but also from scar tissue, we learned to ask some key questions and make that part of our plan. So obviously you need to be familiar with your organization, what size it is, what kind of parts it makes, what are the problems in the organization, are your customers inside the United States, outside the United States. You'll have different business units you'll be working with, primarily in large corporations and in small companies, different product lines, product teams. So you need to go to them and find out from them how AM can improve their business. It's helpful if you're an engineer, you can do these things, but you need to pick their brains and find out where their problems are and stress points. What is the driving force for additive manufacturing in your organization? Something's changed. You're involved. You're implementing additive. Is it financial driving this? Are competitors beating you up because they're using additive? You're not. You see the need for new technology. Do you need to be more forward looking for your customers? Additive can help you in every one of those situations. Next. Am I driving this?
Yeah, why don't you go ahead and advance?
Okay.
Go ahead, I got it.
Oh, we at the same time. So psychologically, too, you need to find out who your advocates are. And the opposite of that is you need to find who your detractors are. So is this being pushed from your management or corporate executives? That's a good one to be pushing for. They're going to provide you resources in the end. So, but where is that emphasis coming from? Is it coming from mid-level engineering and manufacturing management? Is it coming from engineering, manufacturing professionals, designers, others? You need to have a plan for every one of those groups and satisfying their needs and their worries and concerns. The next line is about individual people. Who are the key internal stakeholders? Again, the same group of people, but I'm talking about the individuals now. Some people are going to fight change. Some people, and sometimes that's legitimate. They're very good at their job. They understand the manufacturing methods and the industry, and you're asking them to make a change, and change can be scary. But legitimately, their livelihood, their jobs could be on the line if this isn't done correctly. So you need to make a plan for the advocates and stakeholders as well as individuals. Oop.
All right, thank you, Kevin. So once we answer those key questions right off the start and take a look at the higher level overview, we're going to want to actually analyze our organization. So two parts of this are people and resources. And starting with people, you're going to want to figure out if you have any resources in your company that are experienced with additive. So go ahead and survey your staff and try to figure out what processes and materials they have experience with, what they're comfortable with, what additive knowledge they possess, what training they've gone through, what suppliers they're aware of or they use in their area or part of the org, and what assets are they aware of within the organization. And when I say assets, I mean 3D printers, software, peripheral equipment, anything of that sort. And once you've gone through and found out what the people in your organization know and what they're doing, and I mean, this applies for all levels of organizations, whether they're small or large. I mean, either way, it's going to be a bit easier if you're small, but if you're large, you may have a lot more to uncover and a lot of knowledge that you didn't know about. So you're going to want to go ahead and also try to figure out where those resources are, and those can be done. This can be done in the same survey, but what group in the organization owns the assets is an important point for resources, because if you're going to create an implementation plan, you're going to have to understand how to finance these things and how to either charge back for them or just have a bulk cost center that does all of it in the first place. But finances, if you currently have groups that have machines, how are departments getting parts? How are they paying for them? Is it something like I said earlier where